Hello and welcome to the Gestalt IT Rundown for Wednesday, January 5th, 2022. That's right, it is a brand new year of Rundown episodes, and we can't wait to bring you all of the exciting things that happened while most of the world took a short little holiday break. My name is Tom Hollingsworth. I am the host of the Rundown, but I am not the only talent here. That would also be my friend, my co-host, my partner in crime, Mr. Stephen Foskett. Stephen, welcome to this first rundown of 2022, the Deuces, as it were.
Thank you very much. It's good to be here. And I am trying to put whipped cream on a bird here on National Whipped Cream Bird and Keto Day, but I just haven't managed to make it happen.
That's right. It's always interesting to see what day it is. I know for a fact that I am going to go into the kitchen after the rundown and get a big bowl of whipped cream and put a little bit of pumpkin pie on top, as most people are fond of eating it like that for some strange reason. But that's not the only thing that we have to do, because we have to talk about some of the great news that we saw coming up over the week. And the first one is, well, it's a little bit embarrassing because the folks over at Kyoto University in Japan suffered from a huge data loss back in the middle of December because an errant update caused around 77 terabytes of research data to just be deleted over the course of a couple of days. Now, they did a little bit of investigation, as you might do when that much data goes missing, and they found out that the root cause was an errant software update from HPE that caused one of their scripts to, well, go off script and just start deleting around 34 million files. Very quickly, HPE released a statement where they took 100% responsibility for the issue. Kyoto University then said that they have scrapped the backup system and will be investigating other options, hopefully ones that don't involve data going missing. Stephen, one of the things that you are very fond of telling people all over the world is that the goal of a storage admin is not to lose data. How bad does this look for HPE?
Well, it looks pretty bad for everyone involved. I don't think I would necessarily put the blame entirely on HPE here, because if you actually read the Japanese translated text, you'll see that the script in question apparently was deleting, they found that there was a lot of data just filling up, and somebody decided that it was log files. But it wasn't log files. It was the backup. It was the backup data. And so they adjusted the script to clear the log files, and they ended up blowing away their data. That seems to be what happened here. Frankly, as a sysadmin, myself, as a Unix admin, HPC admin in my past, I can see how this would happen. It's embarrassing. I love Japan, where they could take complete and utter responsibility, and yet, I have a suspicion that this was just a mess for all involved. So, frankly, I think that the takeaway from this is the takeaway from a lot of these things, which is everyone listening should be glad it didn't happen to them, and make a little extra effort to make sure that it's not going to happen to them in the future. Tom, if you're into retro mobile devices as we are, you're probably shedding a little tear this week. BlackBerry devices have finally gone dark yesterday, January 4th. The storied company said that any legacy device running BlackBerry OS 7.1, 10, or the tablet OS will no longer be able to send messages, emails, or even make calls. The cost to maintain legacy server infrastructure have finally eclipsed the revenue from the dwindling user base. BlackBerry had already farmed out manufacturing the hardware to third parties and focused on users and platforms, but the migration paths listed amount to basically get yourself a new device. Tom, is BlackBerry really gone, or is this ghost of Christmas past going to haunt us once again?
I feel like this is the end of a Monty Python sketch. Like, BlackBerry's only mostly dead, except they're really, really dead this time. This has been a long time coming. In fact, when the story popped up on my dashboard, I did that double take of, wait, they weren't dead already? Because for most people out there that know, BlackBerry's service only works because they had a whole bunch of servers that were doing the email relay. I can remember the very first time I ever set up a BlackBerry for some person back when I was still a junior network admin. And I'm like, this doesn't make any sense to me. Like, there's no infrastructure in place that would make this work, until I realized, oh, everything's relaying through BlackBerry servers. But if you remember, like back in the day, everybody wanted a BlackBerry. And even if you were someone who didn't need a BlackBerry, you still wanted the phone because it had the cool keyboard on it. Like, my wife had a BlackBerry Pearl because it was way better than any other keyboard that existed, even though she never used the service. But those services cost money, and they're effectively a private cloud. And when you aren't making a whole lot of money because everybody keeps abandoning your service, you're not going to be able to pay for the infrastructure for the people who are there. I mean, other than the fact that President Obama carried a BlackBerry, a secure hardened BlackBerry, when he first took office back in 2008, when's the last time you heard about BlackBerry doing anything cool? I mean, they ported BlackBerry Messenger to the iPhone. That's how bad things had gotten. So I don't necessarily see this as the end of a journey for BlackBerry, as much as now that they're finally gone, we can kind of put this in the retro mobile device hall of fame, along with, like the Razr flip phone and Palm OS, and we can move on with our lives. And then every once in a while someone will bring up, hey, remember when we used to type out emails on a brick that had a keyboard? I mean, it's going to warm your heart just a little bit. All right, Stephen, when you hear the name Intel, the first thing you probably think of is CPUs. But did you also know that Intel makes a lot of other things, like autonomous driving systems, networking gear, Optane persistent storage? Well, guess what? There's one thing they don't make anymore, and that's flash storage. The computing giant just finalized the deal to sell off their SSD division to Korea's SK Hynix, so that they can spin out that NAND SSD business. I've used NAND SSD from Intel several times, but evidently now it will have a new name on it. What does this spin out mean for the storage industry and the IT infrastructure industry as a whole, as Intel offloads their storage business?
Well, this is part of a continuing pattern from Intel where they invest in ancillary technologies that help boost their core business until those technologies are mature and entrenched, and then they exit because they don't want to be in ancillary businesses. Same thing happened with memory, RAM. Intel was involved in that. And it's happened repeatedly in networking, where Intel would get very involved to spur the use of different networking protocols, different variations of Ethernet, in order to try to get more users on the platform, more data flowing through the CPUs. And that's what's happened here. Intel got involved in NAND flash storage because it was a good business, but also because it helped to support their overall computing platform. It did. NAND has taken over the entire universe. Everybody is all flash storage now, and Intel doesn't want to be in that business anymore, so they sold it off. They announced this deal back in 2020 with the Korean company SK Hynix. Really, the only surprise of this announcement, apart from the fact that it took a while to get approved, but it's finally approved, is that the new company is actually not going to become a subsidiary of SK Hynix directly. It's going to become a company of its own called Solidigm, based in San Jose, California. In other words, the Korean giant is not going to bring all this back to Korea. Instead, they're going to let it continue to be developed and built in San Jose under a new company that they own. And I think that's probably a pretty smart move for them, given the current global economic situation. Also, we're happy to see that Rob Crook is going to be the CEO of Solidigm. We've met Rob at our Tech Field Day events with Intel, and I can't think of a better person to run this new company than him. So, frankly, I think that it's one of those things that is slam dunk for Intel. It's probably a really good business decision for SK Hynix, and I look forward to seeing what they do in the future. I should also note that this is only the first closing. There's actually another closing that's going to happen out in the future when Intel will stop manufacturing NAND wafers at the Dalian memory manufacturing facility, but that's more of a technicality than anything. Really, the deal is done, and this is the deal. Tom, New Year's Day was not a fun time for the Exchange admins. Shortly after midnight, Microsoft's flagship email server started throwing up an error about something called FIPFS antivirus scanning that was unable to interpret the date due to a 32-bit integer overflow. This caused mail to pile up and many people to miss their New Year's appointments. Microsoft quickly issued a temporary PowerShell fix to get the mail flushed out, and a permanent patch to fix the overflow. Tom, what's the deal here?
The deal is that people can't count. And it's kind of interesting because this is not just a problem with Microsoft Exchange. It will be a problem in about 16 years. And let me explain why. All right. So an integer is a value that you store in a system, right? It's a number. And numbers have values, and those values are expressed as exponents. Well, when you express a 32-bit value as an integer, as an exponent, it can be 2 to the 32nd power, minus 1 because we, have to do weird programming stuff. Okay, well, that value is a little bit more than 2 billion. Here's the problem. That value is stored as a signed integer, meaning you can calculate plus and minus from whatever date, right? Now, it's kind of weird that we still use signed integers when we store these values, because I don't know why you would ever want to calculate a negative date. Some people do. It's fine. But the problem is what happens when the number of seconds since that date elapses over 2 billion, 1.4 million? Well, guess what happens? The value overflows, and it suddenly becomes a date that is completely out of the range of the system's capability to comprehend what's going on. In this particular case, it wasn't a date, it was the version number of the scanning engine. They had incremented the version number so much that it overflowed the value. And what happened was that the antivirus engine scanned the value, said this is out of bounds for the possibility of what this could be, and blew up and said, I'm not processing any mail until you figure this crap out. And so Microsoft's temporary fix was to reset the version number of the system to something below the 2 billion limit and allow the mail to process until they fixed it. Now, remember how I told you that this is going to be a problem in about 16 years? Well, it turns out that about 2.14 billion seconds since January 1st, 1970 is January 2038. Why is that important? Well, the value of time stored in a Unix or Linux system is stored as number of seconds elapsed from January 1st, 1970. That is the current epoch for time. Well, guess what? Right after that value overflows, the date resets to 1901. If we don't fix this problem, if we don't start learning to store things either in larger values like 64-bit, which we'll never have to worry about that ever elapsing, at least not as long as we're here, we're going to run into bigger problems. More importantly, though, folks, if you're programming a system and the value that you're trying to store can never be negative, like, I don't know, money or something like that, don't store it as a signed integer. Take the sign off of it, which immediately makes that a 4 billion, and you don't have to worry about this problem. Use your head, please. And remember, it stores it as a signed integer by default unless you specify that it needs to be stored as an unsigned integer. All right, I'm going to get off my soapbox for a minute. It's a 64-bit soapbox, by the way. And we're going to talk a little bit more about money, but the positive kind of money, because one of our friends, the upstart data storage company, WEKA, just announced that they had a big funding round. Now, they were founded back in 2014, and they built a massively scalable, high-performance NAS platform that's recently been gaining a lot of traction in the technical computing and AI space. The company doubled its funding, and in order to kind of pilot this into the future, they brought in a new leadership team to really take it to the next level. Now, Stephen, you're really close not only to the storage industry, but also through utilizing AI. You do a lot of work with AI companies. What do you think of this funding round for WEKA?
Well, this is just great news for WEKA. This is a company that has certainly impressed everyone with their technology. As you mentioned, this is a NAS file storage platform as opposed to the block storage or object storage platforms that we see in a lot of other solutions. And WEKA's system has proven itself to scale, to be secure, to be high performance. But one thing that the company really needed was basically a shot in the arm in terms of sales and marketing. So last year, they brought in our friends Barbara Murphy and Jonathan Martin to help lead the company. And now they've got a big funding round, as you say, a doubling of their funding to basically set them on a path for the future. So this is really good news overall for WEKA, and it's probably good news for the industry as well, since everybody needs a high performance storage solution to fit underneath their big data and AI machine learning processes. So we're pretty excited about this. One thing I'll call out is that the lead investor on this new funding round, which is technically their D round, is Hitachi Ventures. And you might think, oh, I see. So Hitachi, the storage company, blah, blah. No, it's not really it. If you look at who Hitachi Ventures has invested in, they've invested in all sorts of different technologies. Frankly, it's a money business. It's not a storage business. So don't read into too much there. But I would say that this is a good sign overall for WEKA and for the storage industry in general.
Yeah, I would agree. Stephen, we had a couple stories we wanted to take a little bit of a closer look at. And I don't know if you know this or not. Well, you know, but I don't know if our audience knows. CES is happening this week. And historically, that's been a consumer show. I mean, it's right there in the name, Consumer Electronics Show. But the nice thing is that we do often see a lot of announcements that are relevant for the enterprise IT space. And that was certainly the case this week because there were two very big announcements from CPU vendors, Intel and AMD. The first one we want to take a look at is from Intel, which replaced their entire lineup of desktop and mobile CPUs with a 12th generation that they're calling Alder Lake. Now, that's the code name. It's not going to be called that whenever it's finally released. But it's the centerpiece of Alder Lake is the fact that they're doing performance and efficiency architectures combined that mixes the core types in a single chip. In addition, they also announced, a few little things like a brand new GPU, support for PCIe 5, DDR5, and a whole lot more. Now, Stephen, we talk a lot about enterprise IT, but the chips that run enterprise IT are often the ones that are being kind of displayed in these areas. What's your take on these announcements from Intel?
Yeah, I think that it's important to say, first off, that this Consumer Electronics Show really is a consumer electronics show. So we're seeing a lot of announcements of gamer GPUs, of mobile chipsets, of augmented reality, and of course, some big news from Intel's Mobileye subsidiary in the world of autonomous driving. But if we zoom in a little bit on the Alder Lake chips, I think maybe we can use this a little bit to read the tea leaves here. So as you know, there's been a big controversy of basically Intel versus AMD in the server CPU market, where Intel is by far the dominant player, but AMD is really rising rapidly. The world of Ryzen CPUs is growing. There's been so much more interest in the EPYC server CPU line as well. And AMD is starting to get to the point where people are seeing it as a compelling rival for Intel in the data center. So what does that have to do with a bunch of mobile chips from CES? Well, one of the things we can do is look at what the announcements are, because there's a lot of technology shared between mobile devices, desktop devices, and server devices. And the big news with Alder Lake, as you mentioned, is this whole performance and efficiency core thing. So essentially, when you crack open an Alder Lake CPU, what you're mostly going to find is a few performance cores and a few more efficiency cores. The performance cores are the ones that are clocked the highest. They've got the most level 1 cache. They've got the most advanced chipset features. Instructions. Everything it's basically the next generation core from Intel. But those efficiency cores, those are the ones where we start getting interested. Intel can effectively pack 4 efficiency cores into the space of 1 performance core. And the efficiency cores, although they're clocked lower and they don't have all the same processing capabilities, they're very interesting and very exciting. And a bunch of us in the industry are really keeping an eye here and saying, wait a second, those efficiency cores, although they're not present in server CPUs yet, those could be really interesting in the cloud and in the data center. Because essentially what you've got is a whole mess of little, fast, light cores. And if this sounds like ARM in the data center to you, well, it should. So I have been really intrigued by what Intel is able to do in the mobile space with these efficiency cores in terms of processing performance. For example, some of the tests are showing that in general purpose computing, those efficiency cores, which remember are a quarter the size of the performance cores actually outperform some of the previous generation performance cores that Intel has shipped in the past. In other words, Intel could very credibly deliver a massive efficiency core, massive multiprocessing system for applications that need lots and lots and lots of cores. Of course, the other thing that we're seeing here in Alder Lake is PCIe 5 and DDR5, Thunderbolt 4/USB 4. All these other technologies are coming. Intel's new graphics core is here. But for me, really, the thing that I'm keen on is trying to see, okay, if I was Intel's project planners and product planners, and I wanted to look at the ingredients I had for a next generation cloud CPU, I would be absolutely looking at building a efficiency core monster. But there's a problem here, and that is that so far we're not seeing Intel do this. In fact, quite the opposite. My friend Patrick over at Serve the Home notes that Intel delivered some next generation T processors. These are basically their embedded processors for lightweight networking appliances and so on. And many of them lack the efficiency cores altogether. And that's pretty disappointing. So what I'd like to see and what I'm going to see may not be the same thing.
Stephen, I'll echo those thoughts because I saw a lot of the Alder Lake news that came out from different outlets that were very focused on the mobile performance of Alder Lake. And I thought it was very interesting because, well, we'd be remiss if we didn't mention that it's not just Intel versus AMD, it's also Intel versus Apple. And Apple has been doing this in their ARM cores for at least a year now, where they've created, high performance cores and lower performance efficiency cores, both in their mobile devices, whether it's a handheld phone or a mobile compute unit. And Intel's big trumpet was that, we outperform the M1 Max. And my first thought was, and you get 15 minutes of battery life out of it when you do that, because that's the balance that you always have to worry about when you're in a mobile world, is I can run this thing flat out, and I can also choose to have actual battery life. And that's some of the things that we've seen from the testing of Apple's chips with some of the current GPUs that are on the market, some of the high-end performance CPUs, is not so much that they'll run away with the performance. It's that Apple actually purposefully reduces the amount of power that these things can draw so that their battery life is there. And if Intel's going to try to play a game of, well, we'll just outrun everybody, and that's the most important thing for us, is that Alder Lake's performance cores totally trash everybody else's, then my response to that would be, how often do you drive your Veyron at 264 miles an hour on the interstate versus what would happen if we tuned the engine so that it cruises at 70 miles an hour and gets like 80 miles to the gallon? Because that's the real value when you get to the cloud. And you kind of alluded to this, but I wanted to draw out one specific thread here, pun fully intended. This has absolutely nothing to do with the horsepower for what these things are doing in the cloud. Because anybody who's ever tried to buy one of those massive 8 quad core CPU, 1 terabyte of RAM machines and then paid the bill for it a month later will tell you most of your workloads do not need to run on a Gazelle. They need to run on something that gets you to where you need to be with the maximum amount of efficiency. Do you know why cloud providers like the maximum amount of efficiency? Because it draws the least amount of power. I know what kind of power has to run into one of these data centers. And I'm not talking about the ones in Reston and in Oregon. I'm talking about like mid-tier data centers, like those Switch SuperNAT in Vegas. That thing takes an enormous amount of power. There's a reason why they put it there, and it has things like the Hoover Dam. It's because if you can reduce the power of these CPUs to have performance farms that are needed whenever you want to ramp these things up, but everything else runs on efficiency cores when they don't need that, that reduces the power budget considerably. That's a huge boon for cloud providers. Could you imagine what would happen if a cloud provider came in and went, hey, we can offer the same amount of performance to everybody that we've had for the last 2 years, and we can cut our power budget by a third in order to do it? Man, the bean counters are going to go nuts. So I'm with you here, Stephen. Intel is basically, I believe the trope is somebody cut Lex Luthor a check they are trying to beat Apple in performance, and they're trying to kill AMD, but they're sitting on top of a revolutionary piece, this efficiency core, and they're not doing anything with it. They just put it in there because they think it has to be there. So I hope that somebody, Pat, if you're listening, Pat Gelsinger, friend of the show, friend of ours, listen, focus on the efficiency cores, please. This will be better for you.
Yeah, it's funny if you look at the 12th generation Alder Lake lineup. So basically, they're going to be sold as Core i9, i7, i5, and i3, and Pentium, just like previous. There are no efficiency cores in the Pentium, the i3, or most i5s. Only the top i5s get any efficiency cores at all. And then the i7 and the i9 is either 8 plus 4 or 8 plus 8 performance and efficiency. That's basically the difference between the i7 and the i9, is adding 4 more efficiency cores, and effectively then adding 4 more threads. So, man, where's the other way? Where's the 2 plus 8 or the 2 plus 12? That's what I want to see.
Yeah. What we need is, we don't need the Veyron. We need the Toyota Camry. It's slow and efficient and will run forever. Well, Stephen, we talked a lot about Intel, but they weren't the only game in town. Then we have AMD. You know, they've been cranking out really awesome desktop and server CPUs based on their Zen architecture for a number of years. And during CES, AMD premiered their new Rembrandt mobile offerings. But more importantly, they gave us a glimpse at the next generation Zen core, which they're expected to see later this year. Stephen, what makes this Zen core so exciting?
Well, we really have to read the tea leaves here, because AMD did not give us a lot of information about the next generation of Zen. What they did, as you said, was show the next generation of their mobile chips. And frankly, Intel is really leading in mobile, unlike in desktop or in the server, where AMD really has a compelling advantage. The Alder Lake gives Intel a really nice advantage over AMD in mobile. So AMD is bringing their guns that they have to the party here, and so they've got they finally have upgraded the graphics cores, which makes their integrated APUs much more compelling. They also had a modestly dubious presentation talking about how their, even though they don't have performance and efficiency cores, how their performance cores could be throttled down, and they improved the efficiency of them so that they were competitive with Intel. Boy, that is some catch up right there. But for me, the things that I was looking at, again, are the tea leaves that show us where AMD is going next in the server space. Well, number one, AMD's chiplet technology shows us that they're not going to slow down adding cores. They're bringing this technology everywhere. Intel, by the way, is also going to be adopting similar technology soon. At least that's what we hear. But the AMD is not going to slow down bringing massive multi-core systems to market. We also got a peek at the next generation process node that AMD is going to be using. So they've shrunk the process node a little bit, which is great. Of course, that always adds a little bit more performance and efficiency as well. Another thing that they put in here that I think is worth looking at, there was one chip that was from the previous generation, the Ryzen 7 5800X 3D. Now you're like, wait, I thought the Ryzen, the 6000 series was the cool new series. That's true. It's true. But the 5800X 3D is really interesting, because what AMD is doing here is they're experimenting with a new technology. They're actually taking a Ryzen 5000 series chip, and they're slapping on an extra level 3 cache chip as well. So it's like a little sandwich. They only overlap the cache portion of the multi-device module there. So it's a nice flat surface. It doesn't affect heat dissipation. But what they end up here with is a system that has an amazing 96 megabytes of L3 cache. Now they're pitching this against Intel's highest end, 12900 i9s, and saying basically that with all this extra cache, with more CPU processor cores, they're able to compete better. I see this as a little trial balloon of AMD's next generation, which is going to have more of this kind of stacking and more emphasis on more and more level 3 cache. And that is good news for the server space. So if we see in Zen 4 that the chips come with stacked cache, we could end up with a lot more level 3 cache and at a lower price point because of the stacking technology, assuming that it works out for us. And that will be good for everybody in the data center, in the cloud, and AI processing, because level 2, level 3 cache is so important when you're doing that kind of streaming data processing. So I think this is an important advancement. Another thing we've seen is AMD is finally embracing USB 4, which means that they are finally also looking into PCIe 5 down the road, because there's sort of an obvious roadmap from PCIe 4 to USB 4 to PCIe 5. So I think we're definitely going to see that. Another thing we've seen is that AMD has followed Intel in effectively flipping the chip upside down. Right now, AMD processors have all the pins hanging down, and then they go in the socket, and the pins sit in the socket. They're going the other way, so that they've just set the chip on top of the pins. Why does that matter? Well, it matters because it allows you to have more lanes overall. You can have a denser footprint for the chip. You have it better seated, better thermals. And what that means is that we're looking at denser, more IO-centric chips from the company, by the way, that's already delivering a great deal of IO. So what are we going to see in the future? I think we're going to see an even better Zen 4. But frankly, we really can't tell much beyond that from the announcements at CES.
So, Stephen, the question that I have here, kind of regarding these two announcements, we've always seen this kind of difference between Intel and AMD, where Intel believes that fewer cores that run faster are a better performance gain overall, and AMD took the viewpoint of, you like cores, well, we put cores in your cores so you can core when you core, which would kind of lead to this whole idea of sticking an extra L3 cache on the die, because those things be hungry and we need to feed them as much as possible. Could this be kind of a difference in opinion of, Intel kind of chasing Apple's lead of, we need to put efficiency cores in the CPU die because we need to run things a little bit slower and then turn up the speed when we need to, aka turbo mode, versus AMD going, yeah, you know what? You can turn a few of these down if you really want to run in performance mode, but it doesn't matter because we can feed these things so fast that your CPU is not going to be running much at all.
Yeah, that's an interesting conjecture. Combination of a lot of level 3 cache, chiplets, and a lot of flexible cores that really does seem to be AMD's strategy. And I would be very surprised if they change that in Zen 4. So I do expect us to see a lot of cores, a lot of performance cores running very, very fast on little chiplets in the AMD future. But again, if you think about it as a nerd, Intel's direction is pretty cool, isn't it? The idea that you could have tons of little efficiency cores. And I would remind you as well that this is similar to Intel's approach to the Xeon Phi, which was their HPC offering a few years ago. They were trying to use the Atom cores in massive sets of Atom cores in order to give a compelling HPC offering. It worked-ish, didn't set the world on fire, but those Atom cores weren't nearly as good as these modern efficiency cores. So frankly, I think we're going to see that. And again, I'll remind you that Intel also has this kind of chiplet technology. Man, I am excited to see where CPUs go. Between Intel having tons and tons of cores and the performance and the efficiency, AMD just killing it in the market, all these great developments on ARM with like massive multi-core ARM chips coming down, and even dark horses, like RISC-V and so on coming down. There's a lot of cool stuff coming, and we are nothing benefits the consumer more than a battle of providers, and that is exactly what we're seeing here. So I'll get back to what I said in my predictions episode. We are going to see some guerrillas fighting over the market with some very, very cool new technology, and I think that's going to benefit everybody.
Indeed. And just like researchers like Dr. Jane Goodall, we will be sitting here taking notes and providing you with the research and analysis that you need to know who to back in order to win this provider war on the rundown, which will be here every week at 12:30 Eastern time on Wednesday. We will be bringing you the news of the week, some exciting stuff like this, maybe some, ransomware news or something like that. Yeah, it's 2022. I don't think some of the things we talked about in our prediction episode a couple weeks ago are really going to go away anytime soon. And we're not going to go away anytime soon because we love bringing you all the fun and exciting news every week. It's January, so we're getting a slow start into the year. So the week ahead's, the biggest thing for me in the week ahead is Networking Field Day. We have the first event of 2022. It's one of mine. It's near and dear to my heart, being the networking nerd. It'll be happening January 26th through the 28th. We have a great lineup of presenters. If you head over to the website, techfieldday.com, and you click on the link, you can see who's going to be there. Not just the presenters, but also the delegates. We've got a great lineup. And I personally can't wait to hear about some of the cool, exciting new things that are going to be there. We have a couple of new companies presenting, and they're really awesome. Stephen, what's some of the stuff you've got going on that people are going to want to check out?
Well, like you, I'm really excited to some of the future Field Day events we've got going on. We've got Cloud Field Day coming up here, February 16th through 18th. And boy, is that one popular. We've got a ton of companies joining us there, a ton of great delegates joining us as well. And I just can't wait to see these presentations. So Cloud Field Day, then we've got Storage Field Day in March. And of course, I'm really looking forward to AI Field Day, because that is the one where we see a lot of this cool nerdy tech that we've been talking about coming in. Things like, massive chips and neuron processing and GPUs and all this cool tech. So we definitely will be looking forward to that with AI Field Day coming up.
Absolutely. And we bring you the rundown every week. We post the videos on our website at gestaltit.com. We also post them on our YouTube channel, youtube.com/gestaltitvideo. If you're not already subscribed to the channel, please do so, because that allows us to notify you when the new videos drop, not just the rundown, but also some of our unboxing videos, conversations, checksum, all of the great content that we create. We're getting ready to hit a milestone there, and we definitely want to make sure that you're subscribed as well. And also, if you're not already subscribed to Tech Field Day, the YouTube channel, youtube.com/techfieldday, do that as well, because we're always excited to bring you some of the other stuff that we do with our community, and we'd love to hit a big milestone this year as well. So we definitely want to engage with you. So make sure you're subscribed to all of our content, and make sure that you tune in next Wednesday at 12:30 Eastern Time for the rundown. You can also load us in your favorite podcast application of choice. Just look for the Gestalt IT Rundown, and you will definitely find us there. But for myself, for Stephen Foskett, and for the great folks who are part of the Gestalt IT community, thank you very much for tuning in. We hope you have a great day, an exciting week, and we will see you soon.